Okay, right, today we're going to continue looking at some of our quadratic equations. We're going to introduce a new topic, which is going to be called completing the square. It's going to follow on quite a lot from factorising and from the quadratic formula, which we've looked at recently, but it is new, so you're going to have to look through these examples pretty carefully and have a good go at some of these questions yourselves. So let's get straight into it. I'm going to flip you around and have a little look at some examples. So, to start off, let's just talk a little bit about some quadratics. We know so far that to solve quadratics, we've got two methods. The first method being factorising, which we're very familiar with and should be pretty sort of comfortable with at this stage. And more recently, we've looked at the quadratic formula, and we sort of would intend to use the quadratic formula for quadratics which don't seem to factorise. Okay, we tend to use factorising when we've got nice clean solutions. Nice easy fractions, or preferably even whole numbers, but we know that we can get some pretty filthy surd decimal answers for the quadratic formula. The reason is because we have an understanding of what we're doing when we're solving a quadratic. So let's just talk about that before we get stuck into completing the square. I've taken a really easy one as my first example: x squared plus 3x minus 10. Obviously, we're going to solve that by factorising. Factors of 10 with a difference of 3 is 5 and 2, and we need to rearrange those numbers so that we get our output of plus 3x. And obviously, we're going to factorise that to x plus 5x minus 2, which give us solutions, as we know, of x is minus 5 or x equals 2. Now, just thinking about what that tells us, we should understand that what we've just done here with factorising and quadratic is established our x-intercept. So we now know that our curve, and because it's a positive quadratic, is a U shape as opposed to an N shape, isn't that for the negative one, are minus 5 and 2. Those are x-intercepts. Another piece of information which we also know, just from the original quadratic, is that whatever this number on its own, the bit without any algebra attached to it, that's our y-intercept, okay? Just like y equals mx plus c for a straight line, the bit without any algebra is our y-intercept. So we also know it goes through minus 10. Final thing which we know so far already, or we should know, is that our quadratic is symmetrical. Okay, now it's symmetrical around this point, which we're going to call our turning point, or potentially in this case a minimum point. Okay, but we don't really know what this is. Now, we do know that we can probably work it out because it's got to be halfway between minus 5 and 2, which are 7 apart, so it's going to be 3.5 in the middle, isn't it? Okay, but the point is, at this moment in time, we've not got like a particularly solid method for finding this point. This is our best understanding of this quadratic. Minus 5, 2 from our factorising, and minus 10 as well as the shape. So that's where we're up to so far, but we could have done that for any quadratic, I would hope. So let's talk about completing the square. I'm actually going to take two bits of this out at once. We want to focus on solving, but I also want to focus on this black point here, the turning point, because I think it's important that we can get to grips with that as well. We will need to at some stage, so why not now? So let's continue with the same equation. X squared plus 3x minus 10 equals 0. Now, I'm going to try and talk through this. I've got numerous examples which we're going to look at. So if you don't get it first time round, you can always pause, rewind, or you can just move on to my next example, whatever's easiest. X squared plus 3x minus 10 equals 0. Now, there's a little bit of a trick, but what we want to do is we want to halve whatever our b number is. Okay, so ax squared plus bx plus c, the general form of a quadratic. In this case, it's 3. So we're going to do x plus 3 over 2, 1.5, that's half of that, in brackets, all squared. Now, whatever this thing is in your bracket, we're going to take that away, the square of it. So what is 3 over 2 squared? That's 9 over 4, isn't it? So that's why I'm taking away 9 over 4. And the minus 10 is still just from the original. Okay, so this is how we're going to start every single completing the square question. We're going to halve our b number and square it with the x. We're going to take away the square of that number, and minus 10 equals 0. I'm going to show you why that is in a minute. Now, just tidying this up a little bit. X plus 3 over 2 squared, I'm not touching that in a minute. Minus, and if I think about 10 over 4, like get that over 4, that would have to be 40 over 4, wouldn't it? So minus 49 over 4 is me tidying these two things up, equals 0. Now, this is where I want to stop, and this is the extra bit which I just want to add into this discussion. At this stage, where I've just got to, that tells me my turning point. The turning point, really easy when we complete the square, and this is part of the reason why we'd want to complete the square. If we have 3 over 2 here, the x-coordinate of my turning point is the inverse of that. So it's going to be minus 3 over 2, the x-coordinate, which makes sense, doesn't it? That's about right. This thing here, not the inverse of it, just the literal thing which we've got there, minus 49 over 4, is going to be my y coordinate at that point. So just as a little aside, this thing here is my turning point of this curve. So part of the reason why we want to complete the square is it's going to give us an extra bit of information for our sketch and for our understanding of that curve. Now, moving on a little bit further, because we want to talk about how to solve equations, get the minus 5 and 2, we know the answer is going to be from this as well. Well, we just solve this equation. We're going to add over the 49 over 4 to the other side. The next thing which we're going to have to undo, because there's a bracket element here, is to actually do the square root. And we know, because we're expecting two answers, the square root has to be plus minus. Now, 49 and 4 are both square numbers, so it's actually really clean here. Plus minus 7 over 2. And we still have the plus 3 over 2 on this side. We're then going to take that over, and obviously it's going to become minus 3 over 2, plus minus 7 over 2. And here's my two answers. Now, if we think about this, minus 1.5 plus 3.5 is going to be my x's 2 solution, and minus 1.5 minus 3.5, well, that's going to be my minus 5 solution. So let's just pause there for 1 second. Like I say, we're going to look at some more examples. Factorising quadratic formula, for me, are the two primary methods for solving a quadratic. We can solve quadratics using complete the square as well. And that's what we're going to do a little bit of work on, because I think we should be able to do it. But can I just put as an aside, I think these two are the two more important bits for solving specifically. However, to get to this step, we need to be able to do, because it's going to tell us our turning point, which so far we don't have a method for. Okay, so I'm just going to put that there as a little bit of an aside, but that's how I'm sort of thinking about this topic at the minute. Right, let's get some more examples in. So let's start off by talking about generally. First thing which you'll notice is at the minute we are only talking about ones where the coefficient of my x squared is 1, okay? That's really, really important. To complete the square, we need the coefficient of x squared to be 1. Now, just thinking about this, bx plus c, what we're going to do is we're going to have the half of that number b here, isn't it? b over 2, we'll call that then, all squared. Now, the next bit is we're going to take away the square of whatever that is. So that's the square of b over 2. The plus c just remains. So this is like our general format, isn't it, for completing this square. I want to see why that is. I think most people are happy with like, okay, this is half of that, square, fine. The plus c, yeah, fine enough. Why are we taking away the square of this? I want to show you that just very quickly. If we just consider the x plus b over 2 squared, what that means is x plus b over 2 times by x plus b over 2, right? We know that. Expanding this bracket using FOIL, x times x is x squared. Now, the outers here will be x times b over 2, and the inners will be x times b over 2. If we add those two together, we know that o and the I go together. We should agree that we actually just get x squared plus bx. Now, when we did lasso, we do b over 2 times b over 2, which is b squared over 4, multiplying two fractions together. Now, I want you to compare this back to our original. x squared, plus bx, plus b squared over 4. That's why we have to get rid of this term. That's why we have to do this takeaway, because otherwise we've actually changed our expression or our equation. Okay, we're not allowed to change anything, are we? Okay, so the reason we have to take away the square of this is this and this is another way of writing our original. That's what we're doing. We're completing the square. But in order to complete the square, we actually have to be disciplined and take away an element which we don't need. Okay, so that's just a little bit on the general side of things, which hopefully has helped our understanding. Right, let's do another nice straightforward example. X squared plus 6x plus 1. Now, just quickly at the start of this, as I said, factorising quadratic form is still preferable. Now, factorising, it doesn't factorise that, does it? Definitely not. So we're definitely in the territory of getting quadratic formula out here, or potentially completing a square. So let's get straight into it. Remember, we're going to halve our number. So x plus 6 is going to become x plus 3 all squared. Now, remember, we need to lose the 3 times 3 element. So we need to lose minus 9. The plus 1 is still there. Tidy these two up a little bit. We get x plus 3 squared minus 8 equals 0. Now, this is the point, again, where we can get our turning point. It's the inverse of this number, minus 3, and it is whatever this is, minus 8. So the turning point of this curve is minus 3 minus 8. New information there. But let's just finish it off and solve this equation. Add the 8 over, square root it. Now, plus minus root 8, we might need to simplify that to 2 root 2, possibly, if we want it as a third. We also need to bring the plus 3 over. Here's my two solutions. Key thing, as predicted, because it didn't factorise, our solutions here are going to be pretty horrible. Minus 0.172, minus 5.828. Just quickly, remember the symmetry. Minus 3, we're saying, is the symmetry point of this curve. So is minus 3 the same distance away from both of these things? Yeah, it is, isn't it? It's 2.828 away from both of those things. Okay, so that's interesting as a side. So when our coefficient of x squared is 1, we've looked at 2 examples now. The first example here, which had fractions and stuff, and so this was actually a little bit of a harder example probably, and this one here, which is just whole numbers, okay, we need to be able to complete the square. Slightly harder one, and don't panic if we don't get this first time round. What happens if there's a coefficient of x squared? Okay, 2x squared. Oh, hang on a minute, that's not 1. I said that we have to have the coefficient of 1 in order to complete the square. So what we're going to do is we're going to factorise out the 2 from the whole thing. So 2 square brackets I'm going to use here because we're going to use some more brackets in a minute. X squared minus 4x plus 1.5 shut brackets equals 0. Okay, I've not changed anything, I've just factorised out the 2. And all I'm going to do now is I'm just going to park the 2 there for the whole question. I'm just going to focus on what's inside my square brackets, and I'm going to complete the square, just like I have done in the 2 examples you've seen so far. Half of this number, okay, x minus 2 squared. Now, even though this is a minus, we're still taking away the square of it. That's because minus times minus is a positive, so we're always going to have to remove that extra bit. It's always going to be a minus sign at this stage here. Minus 4 in this case, isn't it? Plus 3 over 2. Now, minus 4 plus 1.5, that's going to equal minus 2.5, which I've just tidied up. Still got my 2 parked outside. Now I'm going to start to unpack that a little bit. 2 lots of x minus 2 squared, and 2 times minus 2.5 is just minus 5, isn't it? Equals 0. Now, again, at this point, I've got my turning point. The inverse of this number, that's 2, and whatever this number is here, minus 5. Done. But we want to solve it, don't we? So add the 5 over, divide it under by 2, square root, and obviously we're going to get 2 solutions. So that is just a little bit on completing the square. Hopefully we're going to have a good go at it. Key thing which we need to make sure is that we can get to that turning point stage. For solving, we can use factorising, quadratic formula, or this third method, completing the square. Thanks for watching.